SREB powerful mathematics practices include 5 major indicators. This video will focus on one of those indicators, engaging students in assignments that matter.
Could we do something with this? Because that's the total.
I think a quality assignment is one that all your students are actively engaged. I don't think I had to call down one group today. They were all, well, what do you think this is? Well, let's make this table over here. Well, I see it this way.
So we know it just gives you n squared.
Plug in your n.
It gives you n squared because it only has one dot.
Okay.
They were thinking together. They also had their own different opinions. There was that mathematical discourse between the groups, and together they talked about it.
Over the past couple weeks, we've talked about polynomials.
The teacher frames the assignment by articulating the mathematical purpose as well as success criteria.
What we're going to do today is we are going to build an understanding that operations with polynomials are comparable to operations with integers by adding and subtracting quadratic expressions and by adding and subtracting multiplying linear expressions. Now, before I continue on that, what's a quadratic expression? What are we talking about there? Think back to what we just covered not too long ago. Quadratic. What makes it quadratic? A square. On your whiteboard, write me an example of a polynomial. Okay, once you get one down, hold up your whiteboard.
I always make sure that I frame the lesson to make sure they're on board, they're prepared, and that I can clear up a couple misconceptions before we start the activity. For instance, with the polynomials, I had a student who didn't quite understand what a polynomial was, and that was important for us to go into the activity.
So yesterday, you completed a task called Sequences and Equations. Last night, I looked over your work and identified some of your misconceptions. I've paired you strategically. Today we'll be looking at different dot patterns like the ones we just did and creating equivalent expressions for the black dots, white dots, and the total dots. I have written a few feedback questions based on your misconceptions. Guys, those are on the blue sheet, okay? If you get stuck, refer back to those feedback questions. Those may help you to jog your memory and maybe answer your question before I get over there. So what you're going to do is you're going to take turns to find a match. When it's your turn, explain your reasoning clearly. Guys, that's important. You want to understand. That's the goal of today, is build an understanding, okay? It's not just, okay, she got it. You got to make sure you understand and be able to verbalize that back, okay?
All right, which one you want to start with? This one.
Assignments should be complex, requiring students to engage in problem solving and reasoning to complete. Multiple approaches and solution paths should be inherent in the assignment. Students should take the lead in completing the assignment, with the teacher providing appropriate support and feedback along the way.
Okay, so the first one's already eliminated because there's no white.
Okay.
I tried 2.
So it'll be 2 parentheses 2 minus 1. So it'll be 4 equals 3.
You sure?
Because 2 times 2 is 4. 4 minus 1 is 3.
But you distributed 2 to
Yeah.
the 1.
You distribute the 2 to the 1?
Yeah.
So this would equal 4.
And then
2.
yeah.
Just 4 minus 2 is
2.
okay.
I try number 3 as well.
Be 3 minus 1. So it'll be 9 and 3, so it'll be 6.
Yeah, it would go with this one because it has 6 whites.
Okay.
Oh no. Oh yeah, we were on
6
3.
whites.
I'll try out 4 just in case.
That's 16. 16 minus 4, what is that? 16.
I got 4.
12.
Yeah, yeah, so it works for this one.
That one goes with that one.
I just write it like on top.
As we all work together, we could understand it more and more.
-3 plus 1. Unless it's positive n, but it still doesn't work.
All right, so let's go back to D. So we narrowed those items, all right? So we got our total. What can we do since it gives us this one as well?
Let's see.
What can we do with the black?
4.
Okay.
So I'm saying because the only one for 4 is 2n, and then that gives you 4 times 2 is 8.
Plus
But
1
then
equals 9, though.
the 3 doesn't work. Because 3 times 2 equals 6.
This is, I'm pretty sure it could be I, not D. Because we're solving for D.
Yeah, that's right.
Well, why don't you write it out? It's kind of hard to
Okay.
But there's another negative square. So
why
we
don't-
could try that
Yeah, let's try this.
for D. So how's it
write it
n?
like that.
So M would be black.
N it says -1 divided by 2, right? So we'll try it for the first number 2.
Okay, so
2n.
it'd be no, just 2.
No, because you plug in the n.
Okay, so it's 2n parentheses
Keep going, just a couple
2n
more seconds.
minus 1 divided by 2.
Okay.
So it'd be 4.
So if you distribute, it would be 4 minus 2 divided by 2, right? Then if you subtract, that'd be 2 divided by 2. It gives you 1. So,
Yeah, that wouldn't, because you got one black.
but this one does too.
Okay, so
we'll
that's
try
good.
it 3.
Yeah, keep going with 3. This one has 2 black.
This one has 4, right? So we're gonna put 3,
Okay, let's go back to the spreadsheet.
3 minus 1
3n, yeah, divided by 2. So it'll be 9
minus 3
divided
divided by 2.
2. So it'll be
Divided by 2.
6 minus divided by
First
9.
one, if that's today's.
3 black.
All right, we're gonna have a few people come up and present, okay, their findings. Okay, I want you to listen to think if it's the same as yours. See if it's different than yours, but maybe it gives you the same answer, okay? Karen,
I wanted to make sure that the students weren't focused on, let me just get them done and matched. I wanted to really emphasize on making sure that they understand.
For my method, we figured out the total because 4 times 1 gives you 4, and 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. For our black, we kind of did a chart, and what we did is it goes up by 2, which is our slope, so that one's going to be 2n. And so if you do 2 times 1, it gives you 2, and then there's 3, so then you plus 1, that gives you the black dots.
So for black and white, the equation for black was 2x plus 1, right? And that's it, right? And we could cover this one right here. And there's 2 right here, right? There's 2 right here. So 2x right here. Cover this one up right here. 2x plus 1 that equals 3. This one right here, and I don't really know how to do that one. I mean, it's just 2x plus 1, but it gives you 3. I don't know how to do
So
that.
what he's trying to say is, so there's 2x, it gives you perfect. So there's 1 on each side, it's 2 on each side, 3 on each side, and 4 on each side. And then if you uncover it, that's the plus 1 for the black, so then it'll be 3, and it gives you the corner piece for the plus 1.
anybody do it that way? That's pretty unique. Could we do something with this? Because that's the total. Okay, and look at your blue here.
Plug it in.
Huh, what can we plug in?
The n equals 1 right
Oh.
The teacher's role is to revisit and remind students of the mathematical purpose of the assignment and to provide feedback that moves student learning forward without providing step-by-step directions on how to complete the assignment.
All right, where did this come from?
It's 4%. I think we plugged in the total also.
Wait. See the total. It gives us a total, but like I don't know. Like we don't know how to come up with the equation for white.
All right, let's go back to this one, okay? The total, that means all of them, all right? Let's just look at the 2, okay? So that means that we have a total of how many blocks? We have 8. No, we're not talking about black, just total period. White and black, how many? 9, okay? 4 times 2 is 8, not 9. So does those match? No, okay? So does this one match this?
No.
And if it doesn't match one, does it match any of them?
No.
Okay, so then we need to reevaluate this right here going with this one. That's what I'm saying before you do any of this.
Okay, and then we come up with the white.
And maybe backtrack, yeah.
Okay.
Okay.
We know it's going up by 2s.
Yeah.
Okay. So this, let's pretend
That one's not here.
yeah, let's pretend this one's not here. How many are up here?
4. And then
3,
3, and then 2.
2.
So if we do this one, the total, that would be
16.
But then
So then it'd be 4 squared plus 1, which gives us 17.
All right, I want one of you to stay at your group. The other one, I'm going to give you 5 minutes. You're going to come back, and then your partner's going to go to a different group, and you're also going to converse there, okay? And then I'm going to give you the last 5 minutes to come and kind of put your thoughts together to see if you want to change your answer or add on to what you have. We're going to go this way. So if you know the black now, we know black to be in, how could we come up with a total?
Man, figure it out.
If we know that white plus black gives me the total, we know the black now is in, what would you do to find the total? Go ahead and fill that one in.
Oh, okay. So put just in. I know what to do.
Okay, now,
So it would be in parentheses n minus 1 equals. No. Scratch that. Plus n.
okay, so what would be the total of that?
So you have to distribute this.
Okay.
It'd be n squared, right?
Yes, is that right? Well, is that right?
yeah.
N squared minus 1n plus n.
Okay.
Or equals n.
Is it equal to n or is it plus n?
Plus n.
Okay,
Okay.
so can we do anything else to that? Okay, so what's our total?
That right there.
Okay.
So all we did was add a 1, so then that would give us 5. So 2 squared plus 1 equals 5. So there's 1, 2, 3, 4, 5. So then if you do it here, 3 squared plus 1 gives you 10, and then 9 right here, and then 1 more gives you 10, and then so on. And that's how we got that one.
Let's try this one.
Students critique the reasoning of their peers and engage in productive discussions to build shared reasoning and understanding of mathematical concepts.
Okay, we're going to use 4 in. So 4
Squared plus 1.
4 squared.
So it'd be 16 plus 1 equals 17.
Yeah, 4 squared.
Is that how many is in
4
total?
squared is 16 plus 1
17.
is 17. That's how many black dots there is.
Oh. Even with that one added?
Yes.
Okay.
Okay. Now back on this one, you did the same thing.
Everybody has a different opinion, and everyone has a different perspective of what they're looking at. So if you're trying to come with an agreement on how that problem could be solved, not just by your way, because it could have so many different ways on the way they're looking at it, and then you can come to an agreement and see why that problem is right.
That was a good explanation. I didn't think of it that way. I'm algebraic mind. That's more of a geometric concept. That's good.
As emphasis is placed on deeply understanding and implementing the concept of powerful math practices, ask yourself the question: to what extent do assignments advance mathematical reasoning with grade level or above content in your classroom, your school, and your district?